Welcome to Old School Chemistry. Today we're going to do the ALEKS topic, predicting the single bonded molecular compounds formed by two elements. I have a list of steps for you. Number one, you want to identify, is this going to form a molecular compound? Remember, you're looking for a nonmetal and nonmetal. Second, you're going to do the electron dot for each of the atoms. And then third, based on those electron dots, determine how many you need of each atom so that each atom will have an octet. Let's go ahead and take a look. So carbon and fluorine, nonmetal, nonmetal, I'll say yes, this can form a molecular compound. Remember, molecular and covalent, we can use those synonymously. Magnesium and fluorine, no, magnesium is a metal. Magnesium and fluorine would form an ionic compound. So that one I just leave blank. And when I leave it blank, I leave the entire row blank. Hydrogen and bromine, nonmetal, nonmetal. Remember, hydrogen really special, even though it's on the far left-hand side of the periodic table in group 1, it is a nonmetal. Okay, so from here, we're going to do the electron. We're going to do the electron dots. So let's look at our carbon and our fluorine. Carbon has 4 valence electrons. Remember, on electron dot, I just start at the top and I count how many electrons we have, doing 1 electron on each side like a box, 1, 2, 3, 4. And if there's more than 4, then I just start up at the top again and we double up. So carbon has 4 valence electrons, and fluorine, right here, has 7 valence electrons. Watch this, 1, 2, 3, 4, 5, 6, 7. So this has 3 lone pair electrons and 1 unpaired electron. Now I'm thinking, these both need a full octet. So carbon is going to need 4 bonds. It's going to need 4 of these fluorines, I can see, and fluorine, it only needs 1 bond. I can see how these are going to come together. We're going to have carbon share an electron with a fluorine. That fluorine shares an electron, and it still has its 3 lone pairs. And we'll repeat that 4 times. Carbon will share an electron with fluorine. Fluorine shares an electron. Carbon shares an electron with fluorine. Fluorine shares an electron. And we do that 1 more time. So our final answer on this, the chemical formula, let's go ahead and type it in, is going to be, and I'll click this. We've got our 2 molecular compounds, so carbon, fluorine, and fluorine has that subscript 4. Now the name of this, remember on naming, we say the first nonmetal's name, the second nonmetal, we change the ending to "ide." We also have to tell the reader how many we have. Now if the first element is 1, here's the exception, we don't have to use mono. So if the first element is 1, you don't have to say mono. 4, remember that is tetra. So this is going to be carbon tetrafluoride. Carbon tetrafluoride. Let's type that in. Carbon tetrafluoride. Okay, excellent. Let's come down now to the hydrogen and the bromine. We'll do the electron dots for these. Hydrogen has 1 valence electron, and if you need help with valence electrons, please go look at my playlist and you can watch that video. Bromine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, hydrogen just needs 1 more electron. Remember, hydrogen, it's in the first energy level. It has an S subshell. To have a full subshell, to have a full valence shell, it only needs 2 electrons. So hydrogen has 1, it just needs 1 more electron. That's special. Bromine, 7 electrons, needs 1 more electron to get to that octet, the full valence shell. So this one was pretty easy. Hydrogen needs 1 electron, bromine needs 1 electron. Here we go. The hydrogen will share its 1 electron with the bromine. Bromine will share its 1 electron, and the bromine will have the 3 lone pairs left over. So let's go ahead and type this in. We're going to have HBr, and this is going to be a hydrogen bromide. So we are assuming that these are gases, okay, these are gases. And yes, some of you might be saying, but wait, isn't that an acid? Yes, if this is aqueous, it would be an acid, and yes, we would use binary acid naming, which would be hydrobromic acid. If it's a gas, however, we can say, hey, hydrogen bromide. Honest truth. ALEKS is coded both ways. You can name it hydrogen bromide or hydrobromic acid. It works. I tell my students, let's assume it's a gas, makes it this much easier. You say the hydrogen and then the bromide. Now, I do want to point out, because this is a special hydrogen with the nonmetal, we don't have to put the mono in front of the bromide. I'm sorry, some of the exceptions that we have with naming can be a little bit tricky. So hydrogen with the nonmetal, that does not need the mono with it. So we just say hydrogen bromide on that. Glad we got that one, because that can be a little tricky. Okay, great job. So proud of you. Keep going. You're doing well. Please like and subscribe. I'll see you next time.